Alright, let's do a little bit of a review for our unit. Now, the big idea with this unit is that the forces are balanced. So, all the forces will cancel out one way, shape, or form. So let's do a couple of examples to show you how that works. So this is the notation here. So this is the net force, in other words, the total force. So if you added up all the forces acting on an object, no matter how many there are, so if you had 90 forces, then all of them would total to be 0. So every tension that pulls to the right will cancel with every friction that pulls to the left. So it doesn't matter what the forces are called, but the idea here is that everything will cancel out. So let's say we have something just sitting down on a table, and it's being pulled, but it's not moving. So we've got some forces to the right and to the left. So however hard I pull on the right here is just going to be canceled out by friction on that side. So, and then all of the weight that is acting on that object, so all the force of gravity that's acting on it will be canceled out by that normal force. So the idea is that the forces always cancel. Alright, so let's do an example with some numbers finally. Okay, so a guy is standing on the ground and he has a weight of 700 newtons. And my question is, if that's his weight, then what is the normal force acting on him? Well, if the forces are balanced, then they equal each other. So if he has a force of gravity of 700 newtons down, then that means the ground has to exert 700 newtons up to cancel it out. Let's do another example. I'm pulling a box across the floor at a constant velocity. That keyword is constant velocity. That means the force is balanced. So let's say I'm pulling with a tension of 10 newtons. So I'm exerting 10 newtons of force on the rope. And let's say that the normal force acting on the box is 3 newtons. My questions to you are, how much friction is there and how much gravity is there? Well, they're all equal and opposite, so they're going to equal their counterparts. So if I'm pulling to the right with a tension of 10, then that means the friction is going to be equal to that. If the force of gravity, the force of normal is 3 newtons, then that means it cancels with gravity. So our two answers here are just going to be 10 and 3 again. So the key thing to think of here is tension is 10 newtons to the right, friction is 10 newtons to the left. Normal force is 3 newtons up, gravity is 3 newtons down. Let's do some more stuff. Okay, so we talked about how these things ended up always canceling each other, but let's talk about why. And you may have heard this before, of equal and opposite forces. So if you exert a force on an object, then that object will exert a force on you. So if you stand on the table, then your weight is pushing down on the table, and the table is pushing back up on you. So let's do an example of me pushing against a wall. So I'm exerting a force on the wall of 12 newtons. So the wall is feeling a normal force on itself, and it's by me. So the question is, how much force is the wall exerting on me instead? Well, hopefully you see how this pattern works here. So we first talked about the force on the wall by me. Now we're talking about the force on me by the wall. And they are equal and opposite. So as long as I don't go through the wall or anything weird happens, if I'm putting 12 newtons of force on the wall, it's putting 12 newtons of force back on me. And if we were drawing these in the right directions, we'd have positive 12 to the right, negative 12 to the left. Alright, so let's say we know the friction. Well, if I'm not moving anywhere, then that 12 is also going to be the friction. So friction is going to push back on me with 12 newtons to the right. That's to keep me from sliding. So if the floor exerts a force of friction on me, then that means I exert a force of friction on the floor, and it is equal and opposite. So this is how this works. Whenever objects are directly interacting with each other, their forces will be equal and opposite. So to generalize this into something that we can use for any situation, the force, any force acting on A, or no, excuse me, any force of A acting on B will be equal and opposite of the force of B acting on A. I think I said that wrong. Let me start over. Sorry about that. So, if I exert a force on B, B will exert a force back on me in the same amount, but negative. So that's what we have here at the bottom. So any force on A by B is equal to the negative of the force of B on A. Alright, so when can we use all these tricks here? Well, remember, the whole idea of this unit is when forces are balanced. So when something is either at rest or if it is moving at a constant velocity. So we talked before about an object in motion stays in motion and an object at rest will stay at rest unless there is a net force. So if that net force is not zero, then we do not have something at rest or constant velocity. But for now, those two things will be true. So both of those things will be true, at rest or constant velocity. Alright, I will see you tomorrow.